Hello everyone. In this tutorial video I'm going to explain about the stack operation that will be performed inside the ARM7 processor. So ARM7 processor or ARM architecture we're going to make use of a load store multiple instruction in order to carry out the stack operation. So for a pop operation we are going to use a load in multiple instruction, that is LDM. Similarly, for a push operation we are going to use the store multiple instruction, that is STM. So along with these two opcodes LDM and STM, we are going to use another addressing modes which is called as an ascending and a full stack operation. So we'll get into that, what is ascending and descending. So while doing a stack operation, either the stack will grow up or down in a memory, we know that. And ascending ascending stack will grow towards the higher memory address. In contrast, descending stack grows towards the lower memory address. So upon using this one, this ascending and descending method, we are going to use a one more method which is called as either we are going to make the stack pointer to point to a full stack location or to an empty stack. So full stack means that you are going to point here. Just look this example, take a look into this example where we are going to have some address of the stack. So when I say I'm going to use a full stack, that means as I told you here, full stack, that I'll start pointing to a last data that has been stored inside the stack. So when I'm going to use empty stack, the stack pointer will start pointing to the empty location. So that is from here from this location it will going to start pointing. So full stack operation means it will start pointing to a last data that has been placed inside the stack. When I say empty stack, that means it will going to start pointing to a empty location, the starting address of the empty location. So as you can see here, so this is how I'm going to use this full stack with ascending. Either I can able to use full stack with ascending or full stack with descending. Similarly, either I can able to use empty stack with ascending and empty stack with descending. So these are the ascending modes that I'm going to addressing mode that I'm going to use along with the store and load and store multiple instructions. So when I'm going to use this instruction which is called as a LDMFA, that means load multiple registers, so multiple data with a full ascending. So it will be an equivalent when I'm going to perform the LDM decrement after. So it will going to transfer the data from the stack to the register, and then it will going to decrement the stack. So this is the equivalent operation that will going to be performed whenever I'm going to use this instruction. Similarly, we have full descending, that means increment after. So whenever the data transfer take place, so it will going to take place at the current location which is pointed by the stack pointer, and after the data transfer it will be the stack pointer will be incremented. Similarly with the empty stack ascending and empty stack descending order, that means empty stack ascending means it will going to decrement before the data transfer will going to take place, and similarly for LGMED it will going to be incremented before. So the stack pointer will going to be either incremented or decremented depending upon this addressing mode. So let's get into an example. So now assume that I'm going to have a condition like R1 will going to have a data 02 and R4 will going to have a 03, and the stack pointer is pointing to a location 80014. So this is the example in which it is explaining. The figure will going to explain this rest of the things. So now let's execute this instruction STMFD. As you can see here, so you are just storing the contents to the you are just storing the contents from the register to the stack pointer. So that is what a store means. So you are just going to move the data from the register to the stack pointer. As you can see here in this instructions, you have just used STMFD. That means here STMFD. So that means STM decrement before. So when you say decrement before, that means the stack pointer will going to be decremented one time. So it will going to store the first location. So that means R3 So the value 3 which is specified in the R4, that will be loaded to this empty location, and again after transferring the data, again the stack pointer will going to get decremented one more time, and the next data which is pointed by this register R1 will going to be stored here. So this is how it will going to work. So after the execution of this STMD, so address location will be pointed, the stack pointer will start pointing to the next location. That means the full stack operation as I specified here, so it will start pointing to the last data that will be available in the stack. So the same thing will going to happen with the STMED. So here what I was doing, it was pointing to a location where the last data has been stored, right? So in empty stack it will start pointing to the first empty location, so first empty location from which the data will going to be transferred, as you can see here. So SP is pointing here for the same data set. I have not changed the precondition here. For the same precondition, I'm just going to change the this instruction. So when I say ed, it says that STMED, which is equivalent to an operation doing decrement after. So first it will going to store the data, that is 3, and it will going to decrement the stack pointer. Again it will going to put the register content, and then again it will going to decrement. Now the SP is pointing to the again the new empty location of the stack operation. So this is how you are going to use the stack. You can able to use all those things depending upon the condition that you are in the program. So this is all about the stack operation. Thank you.